Hello all, welcome to the video lecture. This is Ramesh Lama. In this video, we'll be discussing about big data analytics algorithm. As we have already discussed that big data analytics is nothing but the science of examining raw data to reach certain conclusions, which involves examining the data to discover patterns, correlations, insight, and the trends. Like it involves examining the data sets to gain insight or the draw conclusion about what they contain, and what is the correlations and insights of the data and trends inside the data. We can using this data analytics, we can know about the future activity, or we can predict the future activity. So basically there are four types of big data analytics. One descriptive, which explains what happened, and diagnostic, why it will try to answer why did it happen, and predictive, which like what is likely to happen in the future, and prescriptive, like what is the best course of action. So for the different algorithms, uh, we will be discussing about the different algorithms in terms of the type of or type of the big data analytics. Like we will be discussing about the algorithms according to the types. Like first we will start with the descriptive analytics. Like in this topic for the algorithms, I will be discussing with the from the very basic, like from the descriptive statistics to the current state of art, machine learning and artificial technology. So we'll start with the very basics of the descriptive statistics. So we'll start with the descriptive analytics. So this descriptive analytics, it is the process of summarizing the historical data and identifying the patterns and trends. So for this analytics, basically some basic descriptive statistics, such as measure of central tendency, measure of variability, and measure of divergence from the normality, and measure of probability are used. So for descriptive analysis is done by some basic form of descriptive statistics. So for the diagnostic analysis, it is the form of analytics which examines uh, it will try to answer the question why did it happen. So we try to find out the root cause. It's a kind of root cause analysis, and it focuses on the process and the causes. So this can be done by using some kind of probability measurement, regression analysis, correlation, self-organizing maps, cluster and factor analysis, and principal component analysis, and so on. So we'll be discussing about these techniques for diagnostic analysis or diagnostic analytics. And for predictive analytics, we will be using number of algorithms like logistic regression, some Bayesian classifier, descent trees and random forest, collaborative filtering, clustering and categorization. And additionally, we will be discussing about the statistical analysis tools, such as multivariate logistic regression, Kalman filtering, and association rules, lasso and regression, and conditional random fields. And this predictive analytics, basically we use these algorithms to predict or to provide the insight into the future events, or some kind of for the predictive analytics. So these includes some such as supervised and unsupervised learning. So basically we'll be discussing about some kind of machine learning techniques and advanced statistical techniques in the predictive analytics. And for prescriptive analytics, These models determines what actions to take in the order to change the undesirable trend. So this is defined by deriving optimal planning and decisions given the predicted future and addressing questions such as what shall we do and why shall we do it. So basically these analytics, this prescriptive analytics relies on the machine learning and artificial intelligence AI based algorithms. So we will be discussing about some machine learning techniques for prescriptive analytics. So we will begin the different analytics techniques from the descriptive analytics. So before we go with the descriptive analytics, let us see some type of data from the statistical perspective. And there are basically three types of data, which is categorical, ordinal, and interval. This categorical data, or its variable, sometimes also known called the nominal variable. It is one that has two or more categories, but there is no intrinsic ordering to the categories. So it is just the categories without any ordering. Like if we can see some example such as two categories for like male and female. Here we don't see any kind of ordering, just it represents the categories. Or we can see the color of hair, like blonde, brown, brunette, red, and so on. Here also we don't see any kind of categories. So a purely categorical variable is one that simply allows us to assign categories, but we cannot clearly order this variable. And if the variable has clear ordering, then that will be the ordinal variable. Like you can see here, the ordinal variable is similar to categorical variable, but in addition, it will have some kind of clear ordering of the variables. Like we can see some economic status with the three categories like low, medium, and high. In addition to being able to classify the people, these three categories, we can order categories like low, medium, and high. So it is the kind of categorical, but with the order and interval. Like the interval variable is similar to the ordinal variable, but the intervals between the variable are equally spaced. We can see that suppose we have a variable such as annual income that is measured in dollars. So we have three people who makes 10,000, 15,000, and 20,000. The second person makes 5,000 more than first person, and $5,000 less than the third person, and the size of this interval is same. So if there were two other people make 90,000 and 95,000, the size of the interval of these people also will be same. Like like here the 9,000 and the 9,500, the size of the interval would be same. And descriptive analytics, in descriptive statistics, so let us start our topic such as of descriptive statistics. Descriptive analytics, like the descriptive statistics is used for descriptive analytics. So it is the type of statistics which is used to summarize and describe the data set. So it is used to describe the characteristics of data, and they are generally used to determine if the sample is normally distributed. So the in descriptive statistics, it is like the descriptive statistics is displayed through the tables, charts, or the description of the data is displayed through the tables, charts, frequency distribution, and It is generally reported as a measure of central tendency, and it includes the following details about the data, like one is the measure of central tendency and another one is the measures of dispersion or the variability. So let us see the measure of central tendency. Like it's a one of the number of summary, one, like it is a number, one number summary of the data that typically describes the center of the data. So this one number summary, like there are three types. One is mean, median and mode. Like this median is defined as the ratio of sum of the observation in the data to total number of the observations, so it is also known as average. And this mean, thus the mean is the number of number around which the entire data set is spread, so it gives us the central value. And the median is the point which divides the entire data set in two equal halves. One half of the data is less than the median and other half is greater than the same. And the median is calculated by first arranging the data either in ascending or descending order, and then we just find the middle point. So mode is the another number which has maximum frequency in the entire data set, or in other words, mode is number that appears maximum number of times. So the data that can have more than one or more mode, more than one mode, and if there is only one number that appears maximum number of the times, then that has the one mode and it's the unimodal. And if there are two numbers that appear maximum number of times, the data has two modes, or the bimodal. And if there are more than two appear maximum number of times, then the data has more than two modes, and it is also called the multimodal. So it is just the basics about the measure of central tendency, like. And the measure of dispersion or the variability, it describes the spread of the data around the central value, or it is or the measure of central tendency. So the first one is the absolute deviation from mean, and also called the mean absolute deviation. It also describes the variation of data set, and it tells the average absolute distance of each data point in the set, and we calculate it with this expression. Here what we can see is, first we estimate the mean of the data set or the population, and we take the difference of each of the mean from each data point in the data set, and then we take the absolute value and then we sum it and take the average of that difference. So basically it gives us the variation of data set. And another one is the variance. It is the measures how far a data point is spread out from the mean, and it's also same as the mean absolute deviation from mean, but or mean absolute deviation. And only the difference is, like previously we took the absolute value of the difference, here we take the square of the difference between the data point and its mean. So we can say that the high variance indicates that the data point are spread widely, and the small variance indicates the data points are closer to the mean of the data set. So standard deviation is nothing but it's the square root of variance, and we call it as a standard deviation, and it is estimated from the variance, just we take the square root of the variance. So another one is the skewness, and this also, it measures the asymmetry of the probability, which is like we measure, but we will discuss about the skewness and the kurtosis after we discuss about the probability and probability distribution functions, probability distribution and and the probability mass function and probability density function. Basically, talking about the probability, it is the branch of mathematics concerning the numerical description or the measure of how likely an event will occur, or how likely is the proposition is true. So the probability of an event to occur is the number between 0 and 1, where roughly speaking 0 indicates the impossibility of an event, like it will not occur, that event will not occur, and 1 indicates the certainty. And like here, probabilities of all outcomes are always sum to 1, and probability px, like a particular value of probability px denotes a particular value x occur by the probability px. And for example, like flipping an unbiased coin. Suppose if we flip an unbiased coin and we get two possible outcomes, like it may either we will the outcome maybe will either head or it will be tail, and each probability has one outcome, like the outcome may be 1, or the outcome may be head or outcome may be tail. So each has a probability of 1 by 2 or 0.5, or probability of head is maybe the probability of head is 1 by 2, and the probability of tail is also 1 by 2. So, and if we sum all these two, it will give us the sum will be 1. Similarly, rolling a fair die, we get 6 possible outcomes, and the probability of each outcome will be 1 by 6, and total, if we sum all, it will give us the if we sum all the probabilities, then the sum will be 1. So basically this probability gives us the like it is it will tell us how likely an event will occur. So basic terminology, well, let's understand the terminologies that are related to the probability, and 3 terminologies that we often come across when we talk about the probability. Like we have the some non-random experiment, like basically the process, suppose if we are rolling a fair 6 die, and we perform some kind of experiment, and this experiment is nothing but rolling a die. Like what we do is we roll a die, and in experiment, it is basically a process or experiment for which the outcome cannot be predicted with the certainties. Like when we roll a die, the we don't know, or we cannot predict with the certainty, like the output of the outcomes cannot predict certainty, and this is the called the experiment. Like in our case, rolling a die is an experiment, and sample space, the sample space is the entire possible set of the outcomes of an random experiment. It is called the sample space of the experiment here. Sample space, all the possible outcomes of the rolling fair 6-sided die, and it may be 1, 2, 3, 4, 5 and 6, and event is a subset of the sample space, and it is one or more outcome from our experiment. And let's talk about the random variables. Like as we are discussing about the probabilities, or with some examples, like suppose we are about to flip a fair coin 2 times, and record if it shows head or tail, and while we flip, the outcome will be like we are flipping 2 fair coins, so the outcome outcome of the sample space is, it will be either head head or head tail, tail head, and tail tail. So there are 4 possible outcomes, and each of the outcome is equally likely. Likewise, if we have 3 times, like if we are flipping 3 times, then there are 8 possible outcomes, and if we are flipping 10 times, then there will be 1024 possible outcomes. So instead of considering all the possible outcomes, like we can here, like for this experiment, or instead of considering all the possible outcomes, what we can do is we can consider assigning the variable x to the number of heads in the n flip of a fair coin. So we can see here, like if we flip a coin, n is equal to 2 times as above, and then x can take the possible values of 0, 1 or 2, means like the number of heads can take the value of 0, 1 or 2. So by defining the variable x, we created a random variable, and so we can say a random variable as it is a variable that takes different values determined by chance, or it is a numerical description of the outcome of the statistical experiment. So we can see here, like we have here k. K is a numerical description of the outcome of the statistical experiment, or it is the random variable, and there are mainly, and it also gives the probability. And pk, like here we have got the random variable k. This k is nothing but the numerical description of the outcome of the statistical experiment, and pk is the probability of the possible value of the k. So we can see, like when we, for our previous experiment, like k number of heads, this k random variable will have the probability of 1 by 4, and if k is equal to 1, means it is the number of head that is equal to 1 will be 1 by 2, and number of head that will be 2 will be 1 by 4. So this number this pk gives the probability, and this k is the our random variable. And there are mainly 2 types of random variables. One is the discrete random variable, when the random variable can cause only countable when the random variable can assume only the countable, sometimes infinite number of values, then this is the discrete random variable. And for the continuous random variable, when the random variables can assume an uncountable number of values in a certain line interval, so this is the continuous random variable. So now we'll be discussing about the probability distribution. The probability distribution for random variable describes how probabilities are distributed over the values of the random variable. So we can see here, it gives us a list of the possible outcome of the random variable along with their corresponding probability values. We can see, suppose if we are flipping a coin, like if a coin is flipped 3 times, and the sample space will be here as, like when we flip the coin 3 times, this s will be the sample space, will like this will have a total 8 combinations. And we have random variable f is the number of heads, like then x is the random variable, this x is the number of heads as we discussed before, and this px gives us the probability of probability distribution. This px gives us the probability of occurrence of that random variable. So here the probability distribution will be like in this way. This is nothing but the it will it will give us the list of all the possible outcomes of a random variable along with their probability values. Like this gives us the probability distribution function. So for a discrete random variable x, suppose the probability distribution is defined by the probability mass function. So here, like as we have said before, the probability the random variables are discrete random variable and the continuous random variable. And for discrete random variable, and the probability distribution is defined by probability mass function. And the probability mass function, like as we have said, as we describe in terms of function, so we will call it f, and it returns the probability of an outcome. So the probability mass function we write as fx, which is nothing but probability of this x is equal to x, and this function provides the probability for each value of the random variable. So in the development of probability function for the discrete random variable, there are two conditions must be satisfied. One is fx must be non-negative for each value of random variable, means we can see here it must be non-negative, means it must be greater than it must be greater than or equal to 0 and less than or equal to 1. Fx, or the probability value, it lies between 0 and 1. And another condition is the sum of probabilities for each value of random variable must be equal to 1. Like as we take the summation of all the value of the the probabilities of all the random values, all the random variables, this fx, then as we take the summation of all these probabilities of the random variables, it should be the 1. So